So, seem to have a little sound issue, so I'll do a quick recap. We're going to be looking at section 3, combined transformations in their graphs. And in this case, we're going to be looking at two transformations, one after the other. So here is a function that's made of an x minus 3 squared plus 1. So what do I need to do if I wanted to, for instance, sketch this graph or describe the transformations that would be used to sketch this graph? First thing I would have to do, step 1, is identify the basic function, or starting function, if you prefer. In this case, it would be y equals x squared. So, I have pens. These are better to do with pencil, but there is my building block, right? My start function. What's happened to it is two things. I've got this minus 3 here, and I get this plus 1 here. And that minus 3 means move, right? Move your graph to the right 3. And this fella there then says, move, after you've done that, move the new graph up 1. So in this case, start with a key point, like that point there's easy to identify at the origin, and you would move it to the right 3 and up 1, which would basically take it there. And then, as best you can at least, try and draw the same curve. So there is two transformations. You move it to the right 3, and then you move it up 1. So step 1, identify the function. Well, I've done the step. Let's write it down what it is. Identify the transformations. Used. And the order they take place. Well, what is the order, right? Well, there's two things. You move it to the right 3 and you move it up 1. Now, in this particular situation, it wouldn't make any difference, because if I moved it up 1 and then to the right 3, I get the same graph. But that is not always going to be the case, especially when there's reflections being done. If you take a curve and you reflect it in the x-axis and then you move it up 1, it's not the same thing as taking that original curve, moving it up 1 and then reflecting in the x-axis. You actually get quite different shapes. So if you're trying to say, well, what is the right order? I think the best thing to remember is PEMDAS. Parenthesis, exponents, multiply, divide, add, and subtract. In our case, if your parenthesis is the guy in the brackets first, right? So that's the guy you do. And then add, subtract, which is this guy, comes last. So almost typically, you expect left and right to be done before any up and down movements, for example. Let's try something a little bit trickier. Do an absolute value function. So I'm going to do the absolute value. I'm going to do x plus 2 minus 3. Now I'm looking at this function and I would like to do a sketch of it by hand without any software. I would look at this piece here and say, okay, I'm going to start with an absolute value function. I'm then going to do this thing, which we all should understand is move it to the left 2. And then the last thing I'm going to do is this piece, which is move it down 3. So you put all of that together. You start off with your absolute value. You move it to the left 2. So it's now over here. This guy, now you move it down 3. Fix it here. Let's make this guy blue. And this is the guy that you're interested in sketching, the blue one. So these are construction lines. If you do them faintly in pencil, you can rub them out and only need to worry about the final shape being left behind. Okay, let's try 3 transformations. I kind of like x squared, so I'm going to stick to x squared. I'd like to sketch that, but not only do I want to sketch that, I want to write down what the building block shape is and the order as well as the transformations. So I would begin with x squared. Then this guy. That would be move the shape to the right 3. Then, right, so we do the thing in parenthesis first. Then we take care of this negative. And what does that negative on the outside do? It's reflect the shape, the curve. In the x-axis. And then finish with this guy. And we know that this piece says move whatever the graph you've now got, move it up 2. So let's try and put all of that together and see what our thing looks like. There's our starting shape, our building block, x squared. Move it to the right 3. It's now here. Reflect it in the x-axis. Right? Well, if you reflect it, I think I'll change pens. If you reflect it in the x-axis, you see the shape. It's now this fella. And then lastly, take this fella and move him up 2 places. So here. And that, the solid blue one, is the final result. So if you have to sketch a composition of functions or describe what the composition of functions are, this is the way that you would approach that question. Just to prove to you that the order does matter. Let's do that again. Well, it's pretty obvious that you've got to reflect in the x-axis, and you've got move up 2. But suppose you decide to do those 2 transformations in the reverse order. Well, you might say, it doesn't matter, you're going to end up with the same graph. Well, sometimes you do, but sometimes you don't. Okay. So, both of them start off the next square. Nothing to see here. Okay, let's do this one first. Reflect it in the x-axis. Looks like that. Then move this shape up 2. And now you've got that guy, I'll call him A. So the finished shape is A. Now, take this shape, move it up 2. So that's the first thing we do. Now take that shape and reflect it in the x-axis, right? This shape, and you reflect it in the x-axis, you actually end up with this guy. I'll call him shape D. Do you see that they're not the same thing? Look at the position. One's lower than the other. Even if the shape's the same, the position is not. So that's why I'm emphasizing PEMDAS, right? Do the left-right type movements that are in the parenthesis first, then take care of anything that's outside. It might be a factory 2, or it might be a minus x squared, or whatever, right? So let's go crazy with the last one. And let's do an absolute value for it. So it's going to be 2 times, right, the absolute value. Oh, let's make it negative 2. The absolute value of x minus 1 minus 3. So you're going to start with the absolute value function. This bit here, right, it's in, imagine there's parenthesis there, right? It's move it to the right one. Okay. Then you've got a 2 to take care of. That 2 is a vertical stretch by a factor of 2. Then this negative. This is a reflection in the x-axis. Then the last thing you do is move everything down 3. Now that's like the ultimate, anything that can go wrong does go wrong in this question. There is a lot of moving pieces, and I hope I give myself enough room to do it all. So here goes. Absolute value of x. Move it to the right one. Now, to do a vertical stretch, it's kind of hard to do a vertical stretch easily, but what you tend to do in a vertical stretch question is basically, pick a few points and then take that and double it. So you imagine this shape. If you doubled all the points, you just get a very narrow, tall, skinny. It's a bit lopsided, but that's the gist of it. Now, this guy gets reflected. I'm going to change colour now down here. And that's what this one here reflected looks like. And then move everybody down, this guy, 3. So this very solid guy right at the bottom is the final result. So you can imagine that how messy that could be, but hopefully you got what I was trying to get. So I just thought of one more situation. Then I will call it quits. Suppose you are given a graph already drawn. And this graph is f of x. And you're being asked to sketch a transformation. And let's say the transformation is negative x minus 2. Right? So what does that look like? Well, that is move to the right 2. And that guy is another one of those reflect in the x-axis. So let's try this guy. So how do you draw a sketch? Well, the key to doing these is basically looking at the corners, because if you find out what happens to the corners, do the transformation to those points and then just join the dots and you should be good. So if I take all these guys and I move them to the right 2, this guy here is now there. This guy here is here. This one is now here, and this one is now here. And if I join them up, that's move me to the right 2. And then reflect in the x-axis. So take the corners and reflect on the x-axis. That guy stays put. This guy goes here. This corner goes here. And this guy stays put. So that boat shape would be what the graph of this transformation would look like. And that is the end of this video. It's a little bit longer than I was expecting it to be, but sometimes you can't reduce the work any more than I already have. So goodbye for now.